Hello everyone. Today we're going to see the question intersection of two linked lists. Let's just see what the question says. Given the heads of two singly linked lists, head A and head B, return the node at which the two linked lists, you see here the C1 point. So we have to return the point where we see the two linked lists to be intersecting, right? So let's just go ahead and see this. So we have another example. Let's say we have 4, let's say we have 1, let's say we have 8, 4, and 5 as one linked list. And then we have another linked list as 8, 5, 6, 1, 8, 4, 5. So what is the intersection point here in the linked list? The intersection point is 8. Make sense? Right. So you see it's not about the data point because the data point 1 and 1, but these are not intersecting points. The node should be intersecting, right? The address makes sense. It's not about the data inside the node. Okay. So if I see, and also the another case is that if you don't have any intersection, you need to return null for it. Does it make sense? Yeah. So now let me just check on and we will see the approach to it. So let's say you have linked list 1 that goes by 4, 2, 5, 6, 7, and 8. Make sense? And then let's say you have a linked list 2 that goes by 3, 1, 6, 7, and 8. Make sense? Okay. So now what is your, first approach when you see this? What I am going to see is, okay, this is my linked list 1. And let's say my linked list 1 has m nodes. And my linked list 2 has n nodes. Okay. So what is my approach? I will see, okay, is 3 existing in my linked list 1? No. Is 1 existing in my linked list 1? Now for each of this node, how am I going to check? I have to iterate, I have to traverse over the entire linked list. That is, for one node of L1, of L2, linked list 2, I am traversing L1, that is N. I'm traversing M nodes. Make sense? And now for N nodes of linked list 2, what will I have to do? I will have to traverse M into N. This becomes my time complexity. I hope you're getting it, right? I do the same for 1. I go in linked list 1, check if one node exists, not the node with data point as 1, but the same node exists, right? And then I check it for 6. And when I check it for 6, I see it exists in linked list 1 and hence I return 6. Make sense? So this was your approach number 1. Now let's come to your approach number 2. Approach number 2 is basically built up upon approach number 1. It makes use of hashing, right? Because it gives you the search complexity of constant time complexity for searching. So approach 2 makes use of hashing for searching. Why? Because of constant time complexity taken for searching, that is O of a big O of 1. How does it do that? So what I'm going to do is, see, I'm going to take up a hash map. Okay, I'm going to take up a map. And that map's data type is going to be node star. And inside this map, I'm going to put in first every element from linked list 1. Now, when my linked list has been m nodes, I'm going to put in my hash map, right? Makes sense? And then what I'm going to do, as and when I traverse over my linked list 2, I'm going to check, does 3 exist in the map? It's not about the data 3. It's about the node with the data 3. Does this node in its entirety exist in my hash map? Then I'm going to traverse next to 1 and check, Does this node exist in my hash map? Then I'm going to go to 6. Sorry. Yeah. So then I'm going to go to 6 and check. Does this node exist in my hash map? And if it says this node exists in my hash map, I've got my node. So what is the time complexity taken here? So basically it is big O of M plus N. You put in linked list 1 nodes first, then you put in linked list 2 nodes first, and then while you're putting in linked list 2 nodes, you keep checking if that node already exists in your hash map. I hope it is clear with everyone. Next is approach 3. This approach 3 is a little logical approach. So I will just draw up the linked list again. Okay. And then your second linked list goes by 9. Okay. Makes sense? So this is my linked list 1 with M nodes. And this is my linked list 2 with N nodes. Right? This is my linked list 2 and this is my linked list 1. So this concept is built up upon difference in length of linked list 1 and 2. How? So first of all, I will check my linked list 1's length. How much does the length of linked list 1 comes up to be? Linked list 1's length comes up to be 6. Make sense? 1 node, 2 node, 3 node, 4 node, 5 node, 6 node. Make sense? Then I check my linked lists 2 length. How much it comes up to be? 1 node, 2 node, 3 node, 4 node. So what I get? 4. And then what I'm going to do, I'm going to check which linked list's length is lesser. It's linked list 2's length, right? So what I'm going to do, absolute difference of it is 2, right? So I'm going to move its pointer by 2. 1, I move it here. 2, I move it here. And for this, I already have head 1 here. For this, I will move my head 2 here, right? And then I'm going to move these 2 pointers sequentially one step in each of the steps. So with the next case, where do they move to? They come here. And then I'm going to check, is my head 1 equal to head 2? And yes, if it becomes yes, I've got my answer node. Are you able to understand through this? Let's say we had another node here. We had one node as, let's say, 9 here, and another node as, let's say, 1 here. Okay. So in this case, I don't have this, right? So my head should have been here. Head 1 should have been here. Head 2 here. Now, what was the length of my linked list 1? It was 7 and here it was 5. Again, the difference, absolute difference was 2. So my head 2 was moved from head 2, 1 step here, second step here. So head 2 is here, head 1 is here. What do I do? Now with each iteration, with each step taken, I have to move my head 1 and head 2 both equally. Both one step ahead. So I move my head 1, I move my head 2. The head 2 comes here, head 1 comes here. Then I ask, is head 1 equal to head 2? The code returns, no, it is not. Then what do I do? I move it next. Head 2 comes here, head 1 comes here. Now I again ask the code, is my head 1 equal to head 2? The code returns, yes, your head 1 is equal to your head 2. So what do I return? I return this node back. I hope you're getting it, right? So first, what am I doing? I'm finding linked lists 1 length. Then linked list 2 length. And since I can call this O of twice because two linked lists and length of linked list 1, length of linked list 2. Make sense? Right? Then what am I doing? I am moving my pointer by the absolute difference. So it is absolute. Absolute of what? Length of L1 minus length of L2. Then what else I'm doing? Then I am moving it. I'm moving it by what? Minimum, right? Because this was the min length. And in the next iteration, I move my head one from here to the end. So what do? I move it from the minimum of L1 and L2. Right? Now, I hope this concept is clear with you. You know, if you answer it till this approach, I think it's well and good. The other approach, it is built on top of this approach that also has the same concept of the difference in length of linked list 1 and linked list 2. But that is a little not, intuitive. That is what, if you know it beforehand, you know it, right? So if you know that approach before appearing for the interview, you know that approach. But if you don't know that approach, you don't know that approach, right? So let's just see it so that at least you are well armored before your interview. Let's go with the approach 4. Okay. I will drop the linked list again. And let's say we have 5 here. Okay. This is your linked list 1 and this is your linked list 2. This is your linked list 1 and this is your linked list 2. I hope it makes sense to everybody. Right? Okay. Now let's just go ahead from linked list 1 and linked list 2. The next approach that we have. Okay. So what do we do in this approach? We have a head 1, right? This is what is given to us as head 1. And this is what we have as head 2. Makes sense, everybody, right? So we've been given head 1, we've been given head 2. Head 1 marks the head of the linked list 1. Head 2 marks head of the linked list 2. So what are you supposed to do in this approach? You make a dummy 1 pointer. And I will take a different color this time. Okay, which color should I choose? Let's just take this one. Okay. And then you take dummy 2. You move both of them with each iteration, you move them one step forward. So your dummy 1 reaches here, your dummy 2 reaches here. Okay. Another iteration, you move it one step forward. Dummy 1, dummy 2. Makes sense? Right. Another iteration, you move it one step forward. Dummy 1, dummy 2. This is null. Okay. Another iteration, you move it one step forward. Dummy 1, dummy 2. Another iteration, you move it one step forward. Dummy 1. Now dummy 2 was a null. Where should it go? So when your dummy 2 or your dummy 1 reaches null, what do you do with the dummy? You move it to the head of your other linked list. That is, dummy 2 goes to head 1. Make sense? Right? Make sense, right? And with this, what will happen? The next iteration, what do? Your dummy 1 goes to null. Your dummy 2, your dummy 2 comes here. Make sense? Then your dummy 1, what happens to your dummy 1 in the next case? Your dummy 1 goes to your head 2. Make sense? Right? I hope it is making sense to everybody. Then what happens? Your dummy 1, your dummy 1 was here, dummy 2 is here, right? Then what happens? Dummy 2 goes here. And dummy 1 comes here. Then what happens? Next step, your dummy 2 goes here. And your dummy 1, I think I'll have to recreate it. It's getting a little messy for me. So let's just do it again, okay? 1, 2, 3, 4, 5. How many did we have earlier? Okay, we had one more here. I will just create this up, right? And then we had, right. So we had here 7, let's say. So I've just made sure that I've used the same number of nodes so that we can do the concept again, okay? This is what your head 1 and this is what your head 2, right? We started giving your, let's take a new pen. So this is your dummy 1, this is your dummy 2, and this is your null, right? So with each iteration, dummy 1 and dummy 2 are moved one step ahead. Dummy 1 reaches here, dummy 2 reaches here. With this, your dummy 1 reaches here, your dummy 2 reaches here. With this, your dummy 1 reaches here, your dummy 2 reaches here. Your dummy 1 reaches here, your dummy 2 reaches here. So when your dummy 2 reaches to the null, dummy 2 is moved to your head 1. Make sense? And your dummy 1 moves here. Make sense? With next step, what happens? Your dummy 1 moves here and your dummy 2 moves here. Next step, dummy 1 goes to head 2. This is where we did the problem last time, right? So when your dummy 2 now comes to your head, your dummy 1, this is, sorry. Your dummy 1 comes to your head 2. Then what? Your dummy 2 moves here. And then what? Your dummy 1 moves here. Your dummy 2 moves here. And here is the node. Because we are checking on each iteration if dummy 1 is equal to your dummy 2. So what was the time complexity in this case? Though it was same. It was based on your, what do we say? It was based on your difference in length approach. We had the time complexity that went from twice of max length of L1, length of L2. Make sense? Right? Because we went through one step and then again we came through and then we went from here. But we will be doing max of it because one time dummy 1 will be coming from the bigger linked list, and in another instant what will be coming, D2 will go to your longer linked list. So we will have twice it being done. Let's come quickly to the code part. The code is, very simple for this. Find intersection. We have been given a head 1. We have been given a head 2. Right? What are we going to make? We are going to create dummy 1 that points to head 1. We are going to create dummy 2 that points to head 2. Then we're going to write while loop while dummy 1 is not equal to dummy 2. While that is not true, what are we going to do? If my D1 is equal to null, my D1 becomes equal to, D1 points to head 2. Else D1 points to D1's next. In the same, if D2 is null, D2 points to head 1. Else D2 points to D2's next. Then return, either you return dummy 1 or you return dummy 2. Now you would be thinking one thing. What if I have two different linked lists? The the code is going to go in a loop forever? You may be thinking this, right? Because we have while D1 is not equal to D2 condition. So let's see how do we deal with that. And then we have 5 and 6 and 7 and a null case. Make sense? So let's start with it, okay? We have been given this as head 1. We have been given this as head 2. This one we make as dummy 1. This one we make as dummy 2. With each iteration, we move one step forward. Dummy 1, dummy 2, one step forward, dummy 1, dummy 2, one step forward, dummy 1, dummy 2 points to null, one step forward, dummy 1 will point at null, dummy 2 goes to head 1. Makes sense? Next step forward, dummy 1 is pointing to null, dummy 1 goes to head 2. One step forward after your dummy 2. Now, one step forward, dummy 1 goes here, dummy 2 goes here, dummy 1 goes here, dummy 2 goes here, dummy 1 points to null, dummy 2 points to null, and it's done. Because D1 is equal to D2, right? This becomes true. Why? Because D1 is equal to D2 is equal to null in this case. I hope this makes sense. If you have any questions, any concerns, any doubts, please post them in the comment section. You can make use of the G forms attached. You can also let me know of any other questions you want me to take, irrespective of if they belong to the linked list, if they belong to the linked list part of the data structures. Any question, I'd be happy to help you along. With this, thank you so much. Bye-bye.